For decades now, Linux has powered everything from smartphones to supercomputers, and it continues to do so, and it's got a rock-solid reputation. But maybe there is one lingering weakness, and I don't want to get flamed for this, but some might say that memory safety bugs are a weakness. But maybe an unexpected hero has emerged. Rust, yes, the modern programming language, could be the key to making Linux more secure than ever. So the Linux kernel is a technological masterpiece, there is no doubt. But maybe it has an Achilles heel, maybe. And this could be memory safety errors, because these bugs account for a huge percentage of vulnerabilities in the kernel. And even the most experienced C developers can struggle with buffer overflows, use after free errors, and data races. These are non-ideal things to have to contend with. But the problem is that memory safety issues can lead to security vulnerabilities, and nobody wants that. They want an OS that they know is locked down. And exploits have resulted in privilege escalation attacks and system takeovers. Again, none of this is good. And the other challenge is that the complexity of C makes it very difficult to eliminate these issues completely. But maybe we could enter with a new hero. Rust. This was designed from the ground up to eliminate entire classes of memory errors. But here's the twist. Rather than rewriting the Linux kernel, Rust is being used to build new memory-safe drivers and components. But why Rust? Why Rust? Why use Rust? Well, it eliminates buffer overflows and these use after free errors. It prevents data races with strict ownership rules. And it provides safer abstractions without sacrificing performance. That's the key there, without sacrificing any performance. So since Rust was officially merged into the Linux kernel in 2022, progress has been steady. And the recent 6.13 kernel update was a turning point. But why is that? Well, Linux now has the core infrastructure to support Rust drivers across almost every subsystem. We've already got some excellent things implemented. We've got PHY drivers, a null block driver, and a DRM panic screen QR code generator. But what's maybe coming next? Well, how about Android binder driver, Apple AGX GPU driver, and NVMe and Nova GPU drivers? This is just the beginning, but we can expect a whole new wave of new Rust-based drivers in future Linux updates. And after all, the goal here was never to replace C in the Linux kernel entirely. But as Rust adoption grows, it could become the standard for writing new Linux drivers, making the kernel safer, again, without sacrificing performance. And I think we could all agree that a safer and still performant kernel is an excellent thing. So what do you think? Is Rust the future of Linux development? Or is it just a temporary experiment? Is it a flash in the pan, a novelty that's not going to hang around? Let me know what your thoughts are in the comments. I'd love to hear from you. Tell me what your opinion is on this development. And as always, thanks for watching. Feel free to like and subscribe, and hope you enjoyed this video. I can't wait to see you in the next one.